We now moving to chapter 7. We'll talk about impulse and momentum. Impulse J, as you see, it's a vector quantity because impulse is defined as force times time. So J equals F times delta T, and the unit is newtons times second. Then we'll talk about linear momentum of an object, which is the product of mass times velocity, and the unit is kilograms times meters per second. These are two simple definitions of impulse and momentum. Then we're moving on to the next phase. And we'll figure out what really impulse means. Now look at this equation you have. Acceleration equals V final, take away V initial divided by delta T, and all the forces together will be mass times acceleration. So in place of acceleration we can substitute Vf take away V0 over delta T, of course, times mass. So divide delta T on the right side and multiply that with the force. So force times delta T will be equals mass times final velocity, take away mass times initial velocity, and the left hand is your impulse, right hand side is the difference between final momentum and initial momentum. So you can correlate now impulse equals change in momentum. That's a simple theorem, I would say, or a statement. Now let's move on to exercise 1 on page 175. It's a very simple one using definition of impulse and momentum. So you can go over that yourself. Now the next, we're moving to the section 2 of chapter 7, page 177. The principle of conservation of linear momentum. There are two types of forces here. The internal forces, which are the forces within the object when the system exerts on each other. And we'll define external forces, which is outside the system. So we can define force exerted on the objects, which are the agents of external forces on the system. Refer to figure 7.6, page 177. Let me show you the picture now. Okay, there are two objects. One is a smaller one and the larger one. Before collision, they are coming from two different directions, and after collision they hit each other, then they go away in two opposite directions. So the velocity of these two are v01, v02 for the initial velocity wise. Then the force also the same way you can define. Then final velocity is also defined here in C. Okay, now excuse me. Look at that object 1. Object 1, you have work done by the forces, which is W1, and force is 1, 2 exerting on 2, and that equals to the momentum final, momentum initial, the difference is for mass 1. For object 2, you have W2, the work done, and this is the force, so you have M2 times B12, which is final here, velocity wise, and M2 B initial for the second object. Now look at my page 5. The sum of all the external forces plus sum of all internal forces times delta T will be difference in impulse, which is P final, take away P initial. Now from the Newton's law of motion, F12 equals negative F21. So F12 plus F21 equals 0. So now what happens here is that sum of all the average external forces times delta T will be PF, take away P0. So finally you have that equals 0 on the left side, and the difference on right side is P final, take away P0, which is now PF equals P initial. I mean talking about P final equals P initial. In this page we have now M1 times V final plus M2 times V final for the object 2 equals M1 V01 plus M2 V02. So on left side you have final momentum total, right side you have initial momentum total. This is the principle of conservation of linear momentum. Now the next section is about collision in one dimension. Now there are two different types of collision. This type of experiment also you will do in the lab, but you are not doing lab actually, and the manual you read that. Elastic collision means when the two objects collide, the kinetic energy after and before are same. There is no change in kinetic energy, and that's known as elastic collision. And in inelastic collision, kinetic energy after collision and kinetic energy before collision are not the same. That's the basic difference is. Collision in two dimension, which is chapter 7, section 4 is not included for your physics 111. The last topic we have is the center of mass. And look at this picture we have. Which is figure number 14 on page 188. On x-axis, you have M1 and M2, two different masses. The center of mass, that's what we are interested to find out. M1 situated at x1 from this 0 point, and M2 as a distance x2. We got to find out the center of mass, or xc, what it will be. Now look at this equation you have. Which is a very simple equation, of course. X center of mass equals m1 x1 plus m2 x2 divided by m1 plus m2. So there are hardly any 3 sections here to cover for your information. And the problems also will be very simple. For exam purpose, you should focus more on homework problems I assigned you, and I'll be posting some practice problems. So that will be really helpful for your next test. Thank you. Have a good night.